Testing, testing. Am I mic'd? Am I? Oh, yes. I am mic'd. Shh. Okay, well, so nice to see all of you here. Nice packed house for our first event of the year, and welcome to the Daniels faculty. For those of you who may be new to the Daniels faculty, first time here, I'm Robert Levitt. I'm the acting dean of the faculty. So thank you all of you for attending tonight's event. It's the first of our fall 2025 public programming series, about which I will say a few more words in a little bit. Before we begin, I'd like to acknowledge this land on which the University of Toronto operates. For thousands of years, it has been the traditional land of the Huron-Wendat, Seneca, and the Mississaugas of the Credit. Today, this meeting place is still home to many Indigenous people from across Turtle Island, and we are very grateful to have the opportunity to design, plant, grow, be creative, and build communities on this land. As many of you may know, the name of the avenue in which the faculty sits, Spadina, comes from the Anishinaabe and means a place on a hill. This site was also part of an important trail for several First Nations, and as an institution, we are committed to promoting truth and reconciliation and honor these connections as we move forward together collectively. So, on our fall programming, the series begins this evening and concludes in late November and comprises, I think, a very exciting lineup of lectures, book talks, exhibition. It includes a range of our disciplines, of which there are now many, and represents our commitment to interdisciplinary study and practice. I wanted to thank here Michael Piper, who's the chair of the Public Programming Committee, who helped to assemble, I think, a really fantastic series this fall. And it has involved suggestions from faculty and students. So I hope that everybody finds something of interest this fall in the series. Some of the featured speakers and events of the coming season include our Michael Huff, OALA, visiting critic in landscape architecture, and Wystan Spearn, coming from MIT, and her lecture is going to be titled The Buried River, Restoring Nature, Rebuilding Community, and that takes place next Thursday. After that, the Zeidler-Evans lecture featuring Mira Barup-Toft of Nord Architects, and the title of that lecture will be Architecture That Cares, Innovative Healthcare Design, and that's on October 3rd. So, on to tonight's lecture. Tonight's lecture is going to be delivered by our annual Gehry Chair, and that is named in honor of the Toronto-born architect, guess who? Frank Gehry. The Gehry Chair brings an international architect to the faculty every year as a visiting faculty member, teaching in our Master of Architecture program this year, actually also in the undergraduate. Includes a public lecture and, in most cases where the opportunity is possible, an exhibition. This endowed role was established in November of 2000 by Indigo Books and music founder Heather Reisman and 45 other donors. And the holder of this year's chair and our featured speaker tonight, not yet, but is Yusuke Obuchi. Yusuke is an associate professor of architecture at the University of Tokyo, where he has directed the Obuchi Laboratory since 2010 and co-founded the Advanced Design Studies program. Previously, he co-directed the Design Research Laboratory at the Architectural Association in London. That was from 2005 to 10. And he studied architecture at Princeton, SCI-Arc, and here at U of T. And he's taught at Princeton, at the Harvard GSD, Hong Kong University, the University of Kentucky, and NJIT. Yusuke's work addresses some of the most pressing questions facing design, practice, and culture today. So, for instance, Japan's rapidly aging population and shrinking construction workforce are reshaping the future of architecture there, where past strategies, especially during the post-war boom, focused on growth and expansion. Today's realities demand a different kind of response, and one rooted in resilience, care, and long-term sustainability. So in this lecture, Design, Sustainability, and Empathy, Human-Centric Computation Design and Fabrication, Yusuke will explore how computational design, robotic fabrication, and AI-driven systems can go beyond productivity and efficiency to help redefine the irreplaceable human role in construction, drawing on psychological insights such as the Endowment Effect, which is the greater investment in things that we own than those which we don't. His work highlights how empathy emerges when people are directly engaged in making and maintaining their environments. So together, these perspectives suggest a new paradigm where technology and human empathy converge to cultivate more meaningful, resilient, and sustainable futures. Before Yusuke comes up, I just want to tell a little story very briefly that I think is very sweet about Yusuke being here in Toronto. He came to North America as a teenager to hitchhike across the country to explore the continent. I don't believe that you spoke English yet, or very little. Not at that time, so very adventurous. And when he made it to Canada, as he told me, he found a much more hospitable reception and decided to stay. He went to high school here and then began his architectural studies at the University of Toronto, where he made many lasting friendships. And many of those people are here tonight to see Yusuke speak. And I think he's also had a chance to hang out with them. So it's great to have Yusuke back and be part of our community again. He's part of a handful of Gehry chairs who's decided to stay for the full year. So really we'll be integrating into the Daniels community in a very serious way. So we're thrilled to have him here. I'm thrilled to have him here. And please join me in welcoming Yusuke Obuchi to the stage.
Thank you. Okay. Well, thank you, Robert, for the kind introduction. I think you explained everything about my lectures and whom I am, so I don't know what else I have to say. Yes, my name is Yusuke Obuchi. I'm very honored to hold this Gehry chair position and also to be joined again with U of T community. So today, and I also wanted to thank all these people who's been supporting me, Bruce and Shirley, Bridget, and all these people. It's been enormous support for me coming over here. So today, how am I supposed to advance? Do I need to do something to advance? Yes, there we go. So designing sustainability with empathy. Today isn't really about sustainability with efficiency on materials or ecosystems or things like performance of certain kind of structural system, but rather I'd like to focus on how the human feeling towards an object, particularly the object that we make with the cares and some passions and joy, would create tendency towards not just the attachment, but creates the feeling towards an object. Maybe those are kind of things that we need in sustainable culture. So let me just go through some of the ideas. So first, I'm just going to talk about Japanese culture. I'm speaking Japanese, and I do speak Japanese, I look Japanese, but I'm not really thinking in a kind of Japanese way, so I don't know if there's some Japanese here today. So what I'm saying, please don't take it as like a really hardcore Japanese, but this is my interpretation of a Japanese culture. This is the typical view when you walk around Tokyo. You might think this person may be moving somewhere, so packing these oops, packing all these stuff. But in fact, this is to be thrown away, waiting to be picked up by the trash, the garbage truck. It's pretty fascinating to see, nicely packed, everything is labeled because they all pay to be picked up by the trash, the garbage. So, my heart is bleeding. It's like, gosh, in sustainable culture, this is practically brand new. Why would you do something like this? But at the same time, I'm wondering, why we wanted to nicely pack for something to be thrown away? So this is a kind of bit of a puzzle. And I always wonder myself, is this just me thinking about these objects are calling me to be saved? In fact, some of my stuff in my house being salvaged by these kind of stuff on the street. But this is very common things that you see in Tokyo. And here I'm asking myself, do humans have empathy towards an object? Of course they don't, because objects don't have feelings. It's not like animals or human. But could you develop some empathy, feeling towards an object that doesn't really have that feeling towards? So this is the kind of things I wanted to explore today. So this is 16th century paintings in Japan, where this is some sort of guitar-like, it's called biwa, and this is like a harp, it's called koto, and this is a shoe. This is the tools for musicians and performers. And Japanese believe that if you use the tool long enough, the tool will have soul. And after that, if you treat the soul, or if you treat the tool well, it treats you well. If you don't treat well, it haunts you. So they really believe there is some spirit that belongs to a tool. Those kind of things still exist in Japanese culture. I don't know how many of you follow Pokemon. Maybe you love it, maybe you don't know. But for those who know, Pokemon is all these objects. Like this one is this ring, lamps, some gears, everything that we have in our world, in Japanese idea, it has a spirit. So those kind of things that it's not just a traditional, but they do believe in the Shinto tradition that object that we use or attach, it has certain soul. You need to take care of it. That's why you saw these trash. Even trash, you look after them nicely. Even though sustainability idea, maybe you shouldn't be throwing out. Maybe you should use longer. But for those trash that I just showed you, Japanese, it's very expensive to move. So it's rather to get rid of them, buy new one when you move. So it's a kind of conflicting, like sustainability for consume more, but at the same time, you look after things that you're going to discard. It's a kind of very confusing condition. So Shinto tradition is in a very interesting way of approaching towards an object. So this, what you're looking at, are the sewing needles. So when seamstress used the needle for many, many years and thinking, well, it's time to get a new one, they believe that they use long enough that needle has a spirit. So before they discard, they don't just toss it in a trash can. They stick onto a tofu because they've been working so hard for the entire time. For the very last time before it gets discarded, they're going to get nice and soft piercing onto the tofu. Sometimes they do with konnyaku or some soft material. So it's kind of interesting that they really believe to look after them. So this is a ceremony at the Shinto priest and this woman, seamstress, piercing needle into the tofu. This is very traditional things. And you think, gosh, these people are kind of weird. But this is how things are in Japan. And I'm coming from that culture. So what I'm going to show you, you kind of have to shift it. A lot of things are in that mindset. Is it only the object has a spirit or a certain soul? No, the Shinto believes, Shinto is a Japanese traditional religion, but it's not religion in the sense of gods and stuff, but they believe in a certain kind of soul and spirit that exists. Also in the nature, stone, wood, earth, river, all those natural, both phenomenal place, and things like rock has a spirit. So when you go to Japan, when you see these ropes are attached to it, that means that they believe there are a certain soul in this rock, and they go and worship them. A great place for experiencing those nature has a soul, and people look after, take care of them. In architecture is a place called Ise Shrine. Ise Shrine is a fascinating place. If you ever go to Japan, I highly recommend you to go. So for those maybe you know, but for those who don't, so there are two sites. This is the beautiful, by the way, in the forest. Giant cypress trees and all that. But at the core of this forest, there are two sites are dedicated for constructing shrine. One place is, this is the current version. This is built in 2013. So another, every 20 years, they rebuild. So once the 20 years is passed, next one will be 2033, they reconstruct the new one on the next site. So they've been doing this, building new, every 20 years for last 1,300 years. Why they do this? As I said, they believe in all nature, wood, river, earth, rock. They believe in the soul that they have. So the minute the construction ended, the next construction starts by cutting down the tree. So it becomes another ceremony. By doing this, they handed down the knowledge of traditional craftsmanship. The best way, this is like 1,000 years ago, best way to record the knowledge is by doing, by actually practicing, participating. In 20 years, it takes, why? Because it takes 12 years to look for wood, prepare the wood, dry the wood, and next 8 years, they're building the new building, new shrine. And once it's finished, next cycle starts. But during these 12 years, not only cutting down the tree, they sharpen all the tools they have, clothes they wear, everything about this craftsmanship are being handed down in these 12 years, and they make that new one with the actual practice of making. And 20 years is the perfect timing because one person who go into this construction or carpentry, let's say age of 20, and then they'll do that for first 20 years, but 40, and they're handing down the knowledge, and by the time it ends, 60 years. And all, before 60 years is actually pretty much the lifespan of the man that time. So you can hand it down the knowledge by acquiring and also handing, and this is the process of making a shrine. So this is a complete version, just finished, beautiful. So next version will make exact same copy of it, but always transferring the knowledge from one to the next. And you question, so what happened to the old building that got torn down? They take it apart and distribute it to all shrines in Japan, so that every shrine in Japan ideally has some element of this shrine coming from this Ise shrine in order to create this unity of the ideal of the Shinto. So it's a very interesting practice they have. But a core is there is a spirit that exists in the nature. So how does that translate into modern Japanese architecture? So this is a Tadao Ando's building built in 1982. This is the older one. But many Japanese architects, I wouldn't say most of them, all of them, but many of them, carry this idea that good building with care and craftsmanship invites a soul. So it's not about the functionality, it's not about the practicality, but the good building built with cares and really look after. It has this spirit, and if you don't look after, then, as I said in these tools, they come out and haunt you. So it's a kind of very interesting way of understanding architecture than what they built. So this is a kind of Japanese kind of Shinto and how this, let's say, empathy, the object has a feeling that Japanese believe, and you need to communicate, you need to connect it to. So how does that work in a current practice? So let me just quickly go through the current situation in Japan. So this is right after World War II. Japan was pretty much flattened by the bombing, and particularly in Tokyo. So you can see that everything was pretty much flattened. And people like Arata Isozaki and all that, came up with an idea of metabolism, how to really regenerate the city. Not so much about the spirits and all that, but really looking into recreating a new nations. And some of those ideas of producing new building typology and all that was explored. And this is pretty much right now. So Tokyo, in the core, on this area, what you're looking at, it's about 14 million people. But greater Tokyo, because when you go to Tokyo, you can see it's an endless city. It's a 41 million people, and one of the biggest metropolis in the world. So what happened to these 41 people? Or they're still continuing? The stories are slightly different. Oops. So by 2004, it peaked, and they start tanking. So everything after World War II, city was expanding, really creating very functional, as I said, this metabolism architecture very much in the spirit of how to make an efficiency work, how to produce places for many people are looking for a place. But population has very suggesting a different story. So by 2050, about 40% of people are senior citizens. Not only population is shrinking, but at the same time, society is facing what they call the aging societies. The construction industries and just the workforce in Japan has a very complicated conditions where by, let's say, 1997, was pretty much equal between seniors and the younger generation. But what you're looking at 2022, about 40% of people who are working on the construction sites are senior citizens. And very few people, younger people, going to the construction industries. So they have very different condition than after the war, which is they needed the place, there are a lot of people coming, and they have the booming economy. But now economy is pretty much stagnated, population is shrinking, and society is becoming more and more full of, I'm entering that generation, but senior citizens. So one of the solutions for this is the system being explored by construction company Shimizu, that they believe that 80% of construction, because there are no workforce, so they have to get somebody, 80% of construction would be done by robots and 20% by people. So the question is, so what does 20% people do? And what does 80% of construction, how they do it? It's interesting. So here, you're looking at this is a pallet but being moved automatically. So they just go and they take out all the stuff. This is a welding. They do totally automated. This is a ceiling drywall they're putting, and then casting concrete. These are all done in the nighttime. So after 5 o'clock, all the workers go home, and construction get all taken up by the robots that are doing all these things all night long. And when they come back in the morning, people will do the things that robot couldn't do. So this is a kind of very interesting idea that they have, and they're really pursuing that. But as I said at the very beginning, I'm interested in, so where does the spirit or the human connection to the things that you make, how do you make the place has a place for a soul. So what could be the effective design strategy for society or the degrowth? As I said, when expanding, there's a metabolism, all these ideas. We have explored so many different urban design strategies in order to cater the people or the populations are expanding. But we haven't really explored much on the opposite directions. So I wanted to show you some of the projects that I've been working together with a student. I can't do it by myself. Most of the projects I do are within institutions and a very dedicated student, most of them graduate student, to explore the idea. So I just want to show you some of that, how I see that making isn't really about to make things for practical, functional, whatever that reason, but it's really about creating a connection, the human connections. This time I wasn't thinking, I was living in London, but I just want to show you a little bit about where I'm coming from. As Dean talked about, this is because I do a lot of digital fabrication. So some of that, the work that I have done in the past. So this is when I was teaching at AA. The client was sponsor. They asked us to make something out of concrete. They have developed very thin 12 mil concrete that they have the water jet and everything. So try to explore the concrete in a very different way. So we thought, okay, great, concrete. Typically we understand it's a cold, heavy material. How do you make into concrete the light and also very airy? So we developed this very thin concrete sheet that cut all with the laser water jet and created a condition that what we call it bicycle chain structure. So nothing is rigid, but everything has slight movement in order to take up some of the wind load. This was meant to be a fun project. This wasn't like a main thing. We said, hey, let's do some really fun stuff. So this model, it takes us about 2 days to build. And it's like, okay, we can build in 2 days. Well, maybe 2 weeks. We can just put it together. Everything was cut, laser cut and everything, or the water jet. So we said, oh, just all you have to do is just get a whole bunch of people, get together, and just build it. Turned out to be, it took us the entire semester. And this is the AA. Tuitions aren't really that cheap. The students are quite upset. But we started it, so we have to finish it. So you can look at students are really struggling. Why it took entire semester, they call it term, it's simply because if fitting all of those really nicely, but by the time it gets here, nothing begin to fit anymore because the accuracy of the laser, in this case, this is a laser cup, this is a water jet, it's not the kind of human accuracy. So, well, I think I got pages a little bit inside out. So you can see that everything is a finger joint, nicely cupped. So at the very beginning, everything goes nice and smooth. We have these little models that we're looking at. But accuracy of the humans are not, let's say, computational. So if you put in together 100 pieces in sequence, millimeter difference, not a big deal, but at the end of the 100 pieces, it becomes 10 centimeter difference. Nothing fits. So we're building this, spend 1 week, build it, it doesn't fit, we take it down, spend another week, and put it back. And so we're just doing back and forth, and it doesn't fit, so we start cutting into it. So if you start cutting into it, nothing fit anymore. So it became a kind of nightmare puzzle on this project. Although in the end, we managed to make it quite beautiful, but experiment something like this, what we learn isn't really about looking at how beautiful the structure is, but recognizing the difference between the machinic processes of the accuracy, and we don't think about the human do not operate like in the machine. So in the next few projects are looking into not how to avoid making those, let's call it mistake, or accuracy isn't a requirement, but rather inaccuracy. can be a possibility for the design strategies. After I spent about 9 years at AA, I went to Tokyo. The reason going to Tokyo was AA, I don't know, some of you may know, very, let's say, in the bubble, everybody talks the same language and architecture, everybody understands what everybody else is talking. Nothing else exists outside of AA. And I got a little bit frustrated that because we can't talk with other people. Of course we can talk, but people don't seem to understand what we're talking. So going to Tokyo really tried to help me to expand, be in a part of a university, talk to the scientists, talk to different field of kind of academia, but continuing the same, let's say, a learning that I acquired at the AA. So this project, just to simply explain, it's a pavilion made out of chopsticks. It's 1 million chopsticks. I explain why that is. In Japan, as I said, you don't just throw. Everything throw with care, right? So even chopsticks, they don't just toss it. They collect it into the one pile and then put that into some sort of, I don't know, maybe just burn it away anyway, but the process is very important. But I thought, hey, maybe because our labs is not very well funded, so I said, hey, maybe we can use these chopsticks as some sort of building material. At the same time, we're very interested in exploring 3D printing, but once again, we don't really have much budget. So I said, okay, maybe we can develop our own 3D printing machine. Our model is Mount Fuji. Of course, we're in Japan. It's called angle of repose. If you drop the sand, it all becomes about 35 degrees. So it's a very interesting logic that he has. So maybe we can explore that, like making mountain, like Mount Fuji, but not with the sand, but with the chopsticks. What happened was that when you drop the chopsticks, instead of becoming a mountain, you can actually make a wall. They all kind of bind together, but at a certain height, it collapses. It's like, hey, what happens if you drop it together with glue? Maybe we can make this as some sort of 3D printing machine. Very inefficient 3D printer. So we have 3 people. One is holding what we call the 3D chopsticks dispenser. The other guy is cranking, so this chopsticks drops. And this guy, a student, is applying glue as it drops. So I said, hey, let's keep this as a prototype. Let's develop it. This is how we explore digital fabrication. It's not like you guys have some robots. No, we have a human arm and figure out how it goes into the human hand. We explore a whole bunch of 3D printing, in this case, a chopstick dispenser. As you can see, so I'll quickly show you a whole kind of iteration of that. So here's a crank, very analog version. We motorize it to get one person out, so now 2-person operation. And different feeding system with this, and different again. So I'm just going to quickly go through. Final version seems looking pretty good, right? So we got this whole microprocessor that this printer understands where is in the space and how much of the pump that sucks the glue out of it. And so this is pretty much like on a little mini computer, if you like. So how does the things work? It turned out to be quite heavy, so it's a little archaic, but we have to get some sort of extra support to hold this thing. So how do things really work as in a 3D printer, particularly printing chopsticks? So we have, I'm just keep pressing the wrong button. So we have projector, and we have 3D scanner. And projector prints or project color-coded patterns. Green means aim at that 3D chopstick dispenser on the screen. Red means don't aim at it. Blue means you made a mistake. Now, how do you correct the mistake in this situation? Because if you take this green out, this portion out, other becomes purple. So inherently, the mistake is part of the printing problem, or process, I should say. So they're really struggling because we can never get rid of this purple, even though they're told that don't make any purple because you're making a mistake. But at the same time, we do structural calculation based on scanning. So we scan as we print, run through the structural analysis in both to see if that mistakes that continue to go on that direction, like that AA project I showed, nothing will fit, or maybe as we make, we can 3D scan it, run it through the calculation, and maybe we can correct it for the next round of iteration. So it's a kind of real-time scanning, calculation, and then suggesting the next patterns of green, blue, and all that. Make sure that minimizing potential failure of the mistake. This is actually quite higher up, because kind of building up. And this is the final version. So this is supposed to be nice and smooth curve that we wanted to make, but it turned out to be a little bit kind of banged up. But what we thought was an interesting opportunity here, that, as I said, everything is structurally optimized, because as we build, we optimize as we build. So the end you get is optimized ideal form, but not what you wanted it. But so who makes it? What condition? Outcome is always slightly different. So that's a very interesting, because we are obsessed with differentiations and all these. Like, how do you make things different from person next to you? So this is perfect. Depending on who makes it, the outcome is always different. Yet the system is always the same. So we built this giant version with 1 million chopsticks in front of the school. One of the requirements given by the universities has to be public space and practical use. So we built the bench. Make sure that people can feel the structure. That turned out to be a very popular place for the kids. And so this is the kind of final version of that looking from above. So we thought a very interesting way to explore this idea of typically when we understand digital fabrication, it's about the precisions, about the speed, things that you cannot do, but robot can do it for you. But maybe we can turn that whole concept around, that is say, no, we do whatever we want. Computer, you can fix what we do, other than we are being trained to think it like in a computer. So this is kind of next couple of iterations that we're trying to think it in that way, that human are the one that actually making or calling a shot for what to do. Computer is the one that has to fix it. And we wanted to see perhaps the humans are all full of potential, but they're all slightly different. In this case, first one is like color coding patterns. Some people are really good at aiming color coding, and some are not really good at it. But as I said, mistakes are opportunity for design, right? Rather than mistake needs to be corrected. So we kept that same kind of idea. So this time, swinging arm, very simple. Maybe a swinging arm, everybody has a similar pattern of swinging arm, but maybe not all the same. So we created this archive of swinging arm patterns. So there's a whole, about 12 students did all this we made in a library and said, hey, maybe we can use different arm swinging pattern as a design element. So how does that thing work? Oh, before that, it's like, how do you translate this swinging arm into architecture anyway? So I thought, maybe we can spray form while we're swinging arm and magically display, solidify to become stick. So this is the first try. Oops, nothing worked that way. Develop and develop, just like the 3D chopstick dispenser. And towards the end, we got pretty good at making stick that as we wanted it. Again, we developed the 3D, in this case a printer, but with a spray form. As we spray, mesh comes out, the mesh becomes a casing, but the foam oozes out, so it becomes a reinforcement as much as in the formwork at the same time. Very similar idea that, again, mistakes are opportunity for the design. So everybody who can be part of the designer and then also the builder at the same time. And as I said, when we build in Chopsticks, university call us up and say, hey, you can never do the same project again if you are standing above 2 meters. Apparently 2 meters above, you have to have no licenses in construction companies. So, okay, we won't go that. So we built it on the ground, we lifted it. I mean, this is another reason that we use a lightweight material. So this case, so you're looking at here is the red is what we wanted to, and then blue is the one that we actually made it. So you can see a kind of slight difference. So this is you swing it, and swing becomes the form. And we lift it up, and then we do it again. But each time we make the structural analysis, making sure that things won't go in the direction that will possibly collapse. So this is the printed version of the difference between what we wanted it, which is this, and what came out of it. Close enough. Subtle differences. This one's got a huge gash because when they lifted it, they got so confused. So they kind of turn around to see which orientation that they totally forgot. So this where the gash, but again, structurally it's optimized because we run through each layer of the printing. So this is structural analysis suggesting that red means very problematic. Yes, there are some resin, but structural engineers said it's good enough. So he said, yes, we made it. So again, the individual, everyone is different, but how to create a condition where everybody can participate and everybody becomes a part of designer and the fabricator at the same time. And because you build it, you have certain, let's not call it attachment. You have empathy. You feel for the things you build because it's a mistake, but you build it. You want these things to stand up. So you begin to create a connection. So it's not about the construction. You're looking at the working drawing. You have to do exactly what is showing. No, this is, you do it how you think is the best for you. And computer is always correcting what you did. So this is the outcome of that structure. Next one is kind of pushing a little bit. It's like, hey, we did the whole arm. We did kind of color coding. Maybe we can do something completely different. Why not making architecture out of a sound? So the guidance system isn't really about looking at, but hearing a sound. But how do you do that? So we blindfold the student to see if he, in this case Al, can point out where the sound source is coming from. So this is the setup, very crude. So you snap the sound to see if he can identify where sound comes from, to see if we can understand the sound and the kind of comment everybody in the same way. Turned out to be everybody hears the sound in a very different way. And then we thought maybe the setup we have is just so crude. Maybe you have to be more scientific, even though we never do science. So we set up this digital environment where you can hear the source of sound using this special headset that we borrow to see if you can point that sound source. Turn out that everybody has a very different acoustic perceptions. Some people are really good at, and some are not so good at. Like this person, not very good at on the right side. Red means you don't know where the sound is coming from. Green means you know where it's coming from. This person above, the lights, not very good at. So everybody actually, like here too, we all think that we're hearing the same thing, but in fact, everybody's actually hearing differently. So we went through this whole kind of iteration, who hears and who has a particular acoustic perceptions. Chisato, Japanese student, terrible. She didn't know where sound coming from. It's like going like that. Where did Jack go? Maybe it's different. But Sophie too. For those who are gamer, constantly shooting in the video game, they're very good at it, we've found out. So it's like everybody here is slightly differently. But now how do you make architecture out of this whole experiment? It's like maybe we can shoot something like shooting rifle. Okay, but maybe not so heavy, and something light but doesn't shoot too far. So we developed this bazooka, that we shoot coconut fiber. Why coconut fiber? Maybe it's like a dust. Maybe they just aggregate when they bind them together in the one spot. So maybe we can create this whole system of shooting to create an architecture by aiming at the sound. So this is a setup. So we have a fan. She has tracking system, and then she's hearing. So her job is to aim at the sound that she thinks is the right place where the sound coming from. So this is our idea of pavilion out of the shooting coconut fiber. It's actually quite heavy. It's 1 ton of coconut fiber supported by, I forgot how many, but very thin, from 7 mil to 16 mil steel rod in the height of about, highest one is 5 meters. So it's like a seesaw. If you don't shoot properly and land that coconut fiber in the right position, this is going to collapse. So we intentionally create the condition where you have to shoot right, but you know you cannot shoot right. What do? Is the computer is always trying to correct it. So let me just explain how that works. So this is the setup. Because you cannot shoot too far, so we made a hole in the middle. So one setup, I think the next one shows, yeah. So the setup is like you have the shooting gun outside. You shoot coconut fiber towards this canopy that we created. Turn out that, oh, by the way, so everybody, so we had the student, about 20 students. We measure everyone's acoustic perception. So we know Joe is really good at, so he can aim exactly. But the Sophie, she thinks the sound coming from here, but in fact shooting from there or something. So we have to make a reverse engineer, say this person's acoustic perception, we have to reverse engineer. So if you want her to shoot this way, tell her to shoot there. So she'll shoot this. Right? So we created this whole computational algorithm, very complicated, in order to correct their mistake. So they think they're shooting right, but in fact they're completely opposite, but structurally they're shooting the right place. But turn out that while they're doing it, they become good at it, which we don't want that. They want to stay exactly bad at it, but they become good at it. So we have to do another reverse engineer to make it that they do learn, develop, computer undeveloped or unlearn to do the right place. So it's kind of becoming real-time scanning processes of their learning processes at the same time their processes of making. So this is a whole kind of study of machine learning that we have to embed it, making sure that we are shooting in the right place. Otherwise, the structure will collapse. In the nighttime, we have this night team. What they do is they go back and then they scan how much of the steel rods are leaning, meaning that they didn't land that coconut fiber in the right place. So every day we scan, we shot about 100K coconut fibers. It took us 10 days. And then we measure, and the next shooting sequences and who shoots is entirely depending on how much of the mistake they made on that day. So this is in the final version that I think nicely packed without major damage or collapse. So this is a kind of interesting way that how computational processes are helping us not to do the right thing, but we can be who we are, then think what we think is the right is a way to build it. Of course, we're not suggesting this is how high-rise towers should be built and all that. But how do we start thinking about making that it's not, let's say, being controlled by this technologies and all that, but opposite, I think we should be free and we can be who we are because of the technology allow us to do. I don't know how much time, are we go ahead in time? Yeah? Yeah? So, okay, just a few more projects. So, we were invited by UAE, their national pavilion for Venice Biennale. The amazing things that, like you think, wow, it's a whole bunch. But this is, in fact, we got the golden lion for this year. So it's like, you know, let's figure that out, how that happened. It came to us very late. We only had about less than a half year to build it. I guess the architects who won the competition with UAE, they couldn't quite figure it out, so they came to us. This is a project together with Jun Sato, who's a structural engineer, also teacher at University of Tokyo. And said, hey, we don't really have much time. Maybe we can do the Chopstick project, but not the same way. But maybe we build it with what they mean UAE, this whole project. Like they are really into sustainability. They wanted to use a concrete that absorbs the CO2s and all these things. So I said, you know what, I think let's try to figure out how to make it in the most, let's say, democratic way. So very first idea is to create a component in regular shape. We're just gonna make a shell out of this. Again, budget was very low. It's like $10,000 or something. It's just similar to your budget for this exhibition. So it's very low budget, no timing. By the way, the COVID helped us because that kind of gave us an extra year, so we could manage to finish it. But I said, hey, maybe we can just make in a groove, pour some concrete, and make it whatever the irregular shape, and maybe we're just gonna stack them. So this is the whole process. Why are we doing this irregular shape in the stack? Because we wanted to find like anybody who can make the building with very simple instruction using computational process. So let me just explain what that is. So the person who picks up this, let's call it concrete piece or component, and he or she wears this little kind of light that comes on, LED light comes on, when this person is in the right place. So the computer tells you, yes, you're in the right place. Find the spot where this piece, it's quite ragged piece, find the place that it's nice and snug. This would be very difficult to do computationally. Computer is really good at placing, but find the frictions, find the balance, and all of the things are very complicated. Humans are very good at, finding a balance. Like you can, whatever the wall, like there's a certain point that it loses a balance. So we are very intuition. Intuition tells us what is good and not. So it's like, okay, person is told this is the right place, light comes on, and find the place and position them. And then after we have this scanner, it's all kind of hacked computer game equipment to scan where those pieces are finally being positioned. So this is a kind of quick picture that shows, so this is man, he is in the right place, light comes on, and finds the right locations, this will fit. And once it's done, so this is the device, it's just right off the computer game and this is the whole process of making. And after that, it goes back and then scan the center of this piece. It's most of them are kind of a star shape. So finding a center to see where this place was positioned in A. So it's got the whole process. Is it really stable? Just stacking like this. So we have to prove, because this is a national pavilion for UAE. So they said, are you sure this is not going to collapse? It's like, yes. So we did a whole bunch of structural testings and all that. And we have an amazing structural engineer. She created some sort of 3D truss based on this stacking of this random shaped concrete pieces to do all the structural analysis I cannot do, my student cannot do. So in all of these, a collaboration with highly talented people. But and here it goes through a series of structural analysis to go and to make sure that these are nice and stable. But idea is this, that anybody is relatively less skilled, but they are given tools like, hey, find this place, and turn into more like a game. It's like finding a place that's nice and snug. And then they go, and it actually turned out to be perfect for this Venice Biennale during a COVID, because our intention was to send all our students to build it, but we couldn't build it, or we couldn't go there, so we have to ask the Italian contractor who are going to build all these. So all we said was just pick up whatever the piece you have. When light comes on, find a place, just drop it. And we'll do all the rest of it, right? So this is the kind of final form that we got. But idea is that how places like in Japan, where we don't have a people to build buildings anymore. So how to recruit or make even the architectural construction is something exciting and fun, right? Okay, so this is the last project. I just want to quickly show you that how do you make that into construction as also, as I said before, design process, not just putting a material together, but also a fun thing like in a game. So this is a collaboration between ETH and ourselves. This is not ours. This is, of course, you can see it's the ETH project. This is ours for that. So we asked to create a gate. This was originally designed for Tokyo Olympics, which got somewhat postponed, and then this project got kind of relocated in different place. So we were asked to create a gate with sustainability in mind. So we built this gate in Japan. It's called noren, means that if you have this hanging curtain, means welcome. But not only welcome with this, we thought maybe we can create some environmental effect. So all of these are made out of stack of tubes filled with water that evaporate to create some sort of cooling effect. So when you come in, it's nice and cool. Something like this. So you can see all of that. Now, maybe it's a little hard to see, but we have this beam that's supporting this, and we thought, why don't we invite all the local people, everyone to participate in the design? Because our approach is always anybody can build buildings, and how to create a system that, let's say, accommodate their both abilities and their skill sets. So this is the hanging, it's a catenary, by the way, chain, but made out of ceramic. So they all have their kind of geometry created based on their physique, the physical like dimensions, but also capacities. Whoever can carry the heavy one, they get the long one. They cannot carry, they get the small one. And they can it's more kind of exercise. So we created this whole algorithm to see who has that kind of capacity for creating geometry. And the idea is that we scan and let computer figure out where these 2 points are, and then find a place on that beam and making a hole and then place. So it's like kind of, you make geometry, and the computer will decide where the best place to go. So you think, what's the big deal? It's not so big. This is, again, the same kind of scanning system. It's called Vive Tracker. That's off from the video game. So, she is holding it, and that Vive Tracker identify where that piece is, what the tracker is, and then understand the location of it. And because in the catenary, it determined that geometry at the same time. So the rule is, you want it to pack as much as possible, but you don't want it to hit each other. You don't want to cross, but you don't want to have too far either, because you want it to, where it's intersect, you want to bind them to make everything is nice and structurally sound. But at the same time, you want it to have all these pieces as packed as possible. So it's more like kind of a game that you create. The computer will figure out where to put it. Turn out that there are too many options at the very beginning, because effectively you have a piece of wood that you can stick it into anywhere you like. So the first one is, yes, you place, it's like playing Go. I don't know if you play a Go, like you have to put the first piece, next one comes in place in white if you're black, and you're white. It's a kind of process of the kind of interacting with, in this case, the computer. So we place one piece, and the next person who comes and create this geometry. And it's like, okay, we have to put it somewhere, making sure that place has a tangential connection, not hitting. So created this whole kind of gaming-like, that person who decided where to go is hunching or thinking about, if I put it somewhere, then it cannot pack too many, or becomes not so, let's call it nicely designed. There's a little kind of pack in the one area, it's not so full. So creating this whole process of person who's making this geometry, but the other person, not this time, let everything be supported by the computer, but the person is interacting, making a decision to place that where the piece would go. So it's kind of the game in the sense that first you have lots of opportunities to place, but towards the end, you don't have that many. And again, the rule is you want to pack as much as possible, because more the rope, in this case, is the this is big, because in the cooling device, that less you have, the less cooling effect you get. So you wanted to have that density. So this is the whole process of making. As soon as you create that geometry, the robot starts making a hole, and then this has been packed and then placed to create the environmental, let's say, a condition in a kind of conventional way of sustainability that we participated. So I think this is the last image. So with that, I just wanted to thank you again for listening. And once again, that creating, in my approach, creating sustainability isn't all about how to make an efficient building, how to save energy, but if we are to have a feeling towards the things that we make or you use, and maybe then we can use it longer, and that might be the best way to approach to the sustainability in the future. Thank you very much.
So we're going to sit for a few minutes.
I hope I didn't go over time.
It's
A little bit.
a little bit, it's fine.
Okay.
I'm sure everybody wanted to hear from you. Thanks, Yusuke. That was great.
Thank you.
Thank you so much. I came into this thinking about, but occurred to me towards the end of your talk, which is there's something apropos about this being the Gehry chair and the Gehry lecture, because I was thinking, you know, there were many architects like Frank Gehry, and I saw, in fact, Larry Richards gave you a print.
I saw Larry over there. Thank you.
Of a Gehry drawing, and it has it's one of those characteristic quick scribbles, beautiful quick scribbles of Gehry's, which eventually gets turned into a building. And it made me think about this idea of trying to inscribe into the built world something that comes so much from the, I guess, you know, at least in some respects, you know, the gesture of the hand, the human touch. There are other architects of probably people that, I mean, projects that you and I would remember, like Coop Himmelblau's rooftop pavilion or intervention, which also started out as a scribble, then had to be turned into very detailed instructions for someone to build. And then, you know, it's supposed to register in the built world that spontaneity of the hand. But the fact is, in both Gehry's case and in Wolf Prix's or Coop Himmelblau's, that gesture of the hand becomes a very demanding and constraining set of instructions that somebody has to execute. It's very hard. It's not really spontaneous at all. It's a fiction of spontaneity and gesture. So I was just, in a way, I was thinking that you have come up with a set of recursive procedures or back and forths between, you know, there's a conception, I think you, like an idealization, which is I guess the designer's conception of the project, its translation into instructions, and a series of human actions that are errors but are then recalculated by the computer that produces something which is, I think it captures some of that idea of spontaneity and improvisation that is more real than the I guess the fiction of improvisation or that you find in, say, Coop Himmelblau and maybe in Frank Gehry. Anyway, I don't know.
Yeah, our project is just extending Cooper Himmelblau's spirit into the construction. So everyone becomes a Cooper Himmelblau, or everyone becomes a Frank Gehry.
But it's more, to my mind, I guess it's because it has to do with this kind of ongoing procedural set of actions. It seems more real, whereas the other ones were just aiming for that outcome, right? Anyway, I did have another thought. I'm just curious how you think about this, because before the lecture I was thinking, you know, one of the, for people who went through the transition from the analog world to the digital world as designers and architects, you know, it used to be that you would draw lines. The imprecision of that line was, we thought of as a way of finding what we were looking for. And then the first time that you start to use a computer or a CAD system, you draw a line, and every line seems absolute. It seems absolutely precise. It's kind of shocking and hard to negotiate. But then you get used to the precision of the computer, and what you find, like your maybe your subjectivity, your idea of how you translate your idea into design takes on the quality of the absoluteness of the computer, and then when in the world you make things, there's a kind of disappointment because nothing is like that. But you sort of, instead of thinking of your subjectivity existing within the spontaneity of the sketch line, you think of it as being inscribed in the perfection of the computer. I guess I think that somehow you've managed to combine what seems like a lot of overlapping predicaments and sensibilities about design, that you have the idealization of conception, the resistance of the material, which doesn't just let you do whatever you want. You have the gesture built back into the recursive response of the computer's effort to optimize your mistakes. It's a very interesting system. Anyway, I'm sorry, it's not a question, it's just a reflection on what you've done. But I'm just wondering, you know, how you, I don't know if you have any thoughts about your, you know, the own course of your experience from being, you know, moving from analog to computer and to this. I mean, that's a journey I think a lot of people of our age went on.
As I said, you know, I'm not expecting this is an ideal way of using computer to build, you know, architecture, you know, probably not. But I think how we approach towards the making can also be more engaged, more, you know, I think this is like, when you look at this, like, you don't think there's a level of craftsmanship involved, right, because there's a lack of precision. But I see craftsmanship is more to do with how you engage with the material, with the cares, and all that comes, and sometimes expressed in the precisions, and sometimes expressed, in our case, is engagement of everybody who could participate. So maybe I didn't explain it, like everybody can be a craftsman, but it's different way to represent that or express that. And computation allow you to engage and make, because I think at the end of the day, I think I believe that everybody is creative, and tools that we have should amplify a creativity rather than creative process is always in limited people and others don't. Like how everybody's capacities in creative can be expressed through, in our case, in my case, is form of constructions.
Mm-hmm. Maybe we'll come back to some more conversations up here, but if there are there people in the audience who have any questions for Yusuke?
I think she's...
And then up front.
Thank you so much for your lecture. It was like interesting, so interesting. And I mean, like I've been seeing so many projects centered, or like maybe like the efficiency is centered, like they're kind of boring, yeah. And I know like the human participation will bring some interesting to the project, but like during this process, I mean, maybe the things people do will have a bit off, like bit deviation from the computer, like computer calculated. So like the more large your project is, like the deviation is become more significant. So like I was wondering how you're gonna keep like the range between like not deviate so much, but it's like a reasonable. Like for example, like the chopstick one, like how you gonna make sure, like if you didn't scan all of the chopstick, how you gonna make sure like the chopstick didn't fall down or like, yeah.
I don't know if I understand your question precisely. Like, maybe I'm not responding, but a computer is just a tool. It's not, it dictates what you do, but allow you to do things that you cannot do otherwise. So it's just using how you wanted to use the tool. And most of the digital fabrication we approach is we wanted to explore the ideas. So the pavilions are not, it's interesting to have it in the end, but it's not what we are looking for. We are interested in exploring the method of making, which it's not open to many people who can come. So use the sensor, tracking, all of those things are just a tool to help us to make it, let's just call it democratic. Everybody can participate in the form of making. I don't know if I answered your question, but.
One, two.
I just want to say hi from Kevin Weiss, and also, have you considered doing a design where there is no idealized form that you begin with, and you start and let the creator just build something with whatever form or shape or tool they're using, and the computer kind of follows their lead and just kind of make sure it doesn't fall down sort of in the end? Have you done one without a final design, or is that a possibility for you?
I'm sure it's a possibility, but we always have a design. We always treat it like how plants grow. Plants has seeds, and the seeds will have a particular trajectory of how it grows. So me as an architect, I design, but how it takes its own course, I have to accept the differences from how I projected it. So like plants, as I said, metaphor, if the seeds get planted in a shady spot, sunny spot, windy spot, they all grow in a very different way. I kind of take the architectural production in a similar way, but I do still have a DNA, I still have a design. But my role isn't to dictate the outcome. I'll let other forces to participate in the process of design. So the outcome is the history of all the participations and engagement on the conditions that register in the final form.
I have a question over here. Sasha.
Yusuke, watching this presentation, it strikes me that the process is a lot like a dance. Only you're dancing with what we would often think of as an inanimate object or material. But the fact that everybody who works with that material ends up with something slightly different, that gets back to the sense of these objects, these materials having a spirit. And is it, in a way, in this process of dance that the spirit in the object comes out?
What kind of dance? Like a tango?
Like any dance where you have, I mean, yes, anything like it would be something like a tango or something where there is contact, not just, you know, the free form kind of flailing around. Because when you think of, let's say, a more classic dance, there are certain steps, there are certain movements. Any two people can do them, they can execute them, but every time you do it, it'll be a bit different. Everyone you dance with, it'll be a little bit different, in the same way that every person who tries to put these things together, it just comes out slightly different from what you had planned.
Yes.
But it's still all the dance.
Right. So maybe it's similar to the question before. Like, I'm not saying that anything goes is okay. It's actually very formalized. And there's particular kind of method that you created, the system that we created, but we're operating within a highly constrained system. Anything that happens within the margin of error, let's call it, becomes acceptable input for the design outcome. So,
As in a tango, as in a waltz, as in a foxtrot.
Yes.
You know.
But it's interesting because you did show the temple reconstruction before, and one of the things that's, you know, a kind of peculiarity of that method of reconstruction is the persistence of the form in its in its identity. No, so it's, I mean, what you do is in fact quite different, because in the temple reconstruction there's very little permission for the impact of individual, let's say, talents or sensibilities.
yes. So I'm not aiming for perfection.
Yeah.
I'm actually kind of opening that.
So yours is really almost a counterexample to the temple. It's, sure. Okay. Yeah.
Hi, I just wanted to say thank you so much for this. Of your pavilions, the designs seem to invite a unique interaction with its visitors, and I was wondering if you saw any surprises in how visitors experience the pavilion versus its intended use.
I would love to have that pavilion to be very public and open and say whatever they wanted to, but because it's in the university, say, premise, so we couldn't let people just start climbing and all that. So, but most of the, I don't know here in U of T, but University of Tokyo, campus is like a kid's playground. There are lots of nurseries and kindergarten around, and the campus are full of kids. So, you know, even though professors and graduate students, they all walk by, they don't seem to pay attention, but attracted a lot of kids. So, like you saw a couple of the pictures, like typically it was full of kids. So we are kind of always chasing, make sure they not climb, they not start shaking that stuff. You know. So.
Hey, sorry, over here. Oh, stand up? Okay.
Just so we can see you. It's
All right.
nicer.
I really appreciate the evolution of your almost like your approach, like saying like the analog all the way to using more like computational, like artificial intelligence, like that kind of analysis. So I feel like it's really befitting that, now we're in this age of generative AI and people can create whatever they want. There's this like trend where people are vibe coding and doing things with technology and really making technology and creation so accessible. So I think in this very exciting era, what's next? Like what do you see next in this? I don't know, almost like creating for the public, where anyone can create. Like what is the next step in both your personal career, or what you see envisioning in the future, or also even like from a general sense of creation?
The project, the last one I showed you, that was like 3 years ago that we finished. So we're currently working on the project, but we haven't put document together. So, but I'm collaborating with a series of architects in Japan. That one, I don't know if my students are here today. I told them to make sure to come, but maybe they didn't. So we're collaborating with architects in Japan to restore and also to create the community for the island. It's very kind of aging society. The average age of this age of this island is about 75 years old. So because there are a lot of these social issues is facing Japan, so I would like to spend more time to kind of think about how to deal with these situations that face in Japan. And the particular project that, if you were asking for, very banal, but it's like stacking stones actually, like creating, even though it's quite beautiful, like how to stack the stone computationally, but not just optimizing with geometries and all that, but how the human feels the rock, how heavy that is, and finding a balance. So almost like creating a structure that's over hundreds of years old. Sorry, my mic is not really picking up the sound, but yes.
Okay.
Hi there. Thank you very much, Yusuke. It's been really interesting listening to your presentation. I used to work for Stantec and previous to that Murphy Hilgers. And now I took a master's in innovation, and I really have to tell you, I saved my chopsticks as well. But I wanted to mention to you that I think this is really great for design house like you could use these ideas everywhere in innovation from wide-scale use, because what I really was interested in was the timing on how it took you, because I have an invention that I want to deploy, but I wanted to ask you, how long did it take you to make that 3D printer, or even the different iterations that you used?
Typically
and also
one semester.
The computer, you must have used the same type of idea for the computer iterations to create the idea of how to intertwine the human empathy with the computerized invention that we see today on the screen.
So our lab.
How long would that have taken? I was curious.
So we have about, when I did, let's say, the Chopsticks project,
Right.
we had about 16 students working on the various aspects of that project and graduate level. I mean, I'm very fortunate, very bright, very talented student. They're much better than what I can, imagine doing. So they already know how to do the whole, digital scriptings and all that. So I can kind of wave my hands and they can kind of do that. But it's typically one semester.
Perfect.
So my role is more kind of cheerleader.
Right, but it's really
So
exciting to see
I'm just,
what's happening.
hey, let's, kind of.
So you have a deadline. Your deadline is a semester.
Did you hear that, my student?
Well, keep on innovating. Thank you.
Thank you.
And I think that it's 8. So Yusuke, it was great to hear about what you're up to and have an opportunity for you to present to everyone here. Great to have you for the year. So thank you for that.
Thank you.
So just before you all go, I just want to remind you again that Ann Winston Spurn is coming next week, and to keep your eyes open for our website and announcements on upcoming lectures. And the Howarth Wright exhibition is going to be opening on September, when is it opening? It's it's 23rd, thank you. The Howarth Wright exhibition is opening on the other side of this wall. It is a very interesting exhibition about the impact of a fellowship that's given to our to students who've gone to study Wright and then produce projects that come from that. So a number of our alumni have their works, as well as a lot of interesting documents and memorabilia about Wright, some of which come from Larry Richards' private collection. So keep your eyes peeled for that. Not quite ready yet. So thank you everybody for coming tonight. See you next time.